So number 5, again a free fall. Well, it's in the title, so that helps. A rock is thrown vertically upward from the edge. Well, same cliff, same situation. But here's the difference. We are at the edge. And what is the difference between the previous problem and this problem? What is the keyword that tells us that something is different? Yeah, not only thrown, but vertically and upward. So that vertically keyword tells us it's a one-dimensional problem. We go up and down. Thrown means V naught is not equal to 0. And upward means that we go up. So R is going to be up to you, Jimmy. If we decide to have our y-axis vertically, then only yes, only y, yes. But if you decide, well, you know, I don't like the y, I'm going to use x, then you set up your x-axis in the vertical direction. So it's up to you. Yep. Only a one-dimensional problem, but as we've seen earlier, you still need 2 axes. Why do you need 2 axes? Why did I need this? This told me what about my equations? The location of my x-axis, even though everything takes place in the y direction. Something about simplifying my equations. So one of those variables was affected by my choice of where the x was versus here. Be specific. Which variable was affected in here? Which variable is affected by the axis that we technically don't need? Yeah, the initial position. Excellent. Okay, so when you use a coordinate system, this is useless to you. This is useless to you. This is useless to you. And this is useless to you. This is useless to you. The only one that's useful is 1 plus on each and correct level. And the position of this guy will affect your x naught value. Or you pick this. Doesn't matter. But it has to be orthonormal. You have to show yourself both axes, and you have to be very clear about where this goes. That's why we draw a diagram. Excellent question. I forgot who it was. Scroll back up, scroll back up. Jenny. Okay? So, let's go back. Where am I? Okay. So, obviously, in this case, the keyword saying thrown vertically upward, our rock is going to do something like this. So, first it's going to go up, and then it's going to go down. Okay. It leaves your hand at a point even with the edge. Okay, so it's right here. And at a speed of 25 meters per second. Oh, keyword, speed. What the heck is this? Almost. Almost. If it was the same as velocity, then we wouldn't have 2 different words. Almost. In this case, it is related to V naught indeed, because it's related to velocity at the initial time. But by definition, what is the difference by definition between velocity and speed? It has to do with vector and just definition. Excellent. The speed is just the magnitude of the velocity. The velocity is a vector, therefore it has 2 properties, direction and magnitude. Speed is just a stupid scalar. It represents only the magnitude. Excellent. That's why it was good that we're being told upward. The upward tells us the direction of V naught. 25 tells us its magnitude. Okay? Upward tells us V naught is up, and 25 tells us that magnitude V naught is 25. So the problem tells us that V naught vector is 25 meters per second up. Good. Let's keep that exactly. Absolute value of V. Good. The rock is then in free fall. Okay, good. On its way back down, it misses the edge and continues to fall. Okay. So let's write down our generic equation as before. So you always want to start from those. So as you're going to use them over and over and over, then that's how you're going to memorize them naturally. Well, what am I doing? Obviously, I haven't practiced enough. There we go. Okay. So, let's change the order to spice things up. First, which current stem would you like to pick? And second, where would you like to put the origin? Second means, woo-hoo-hoo. All right. So Henry, let's follow his lead. Origin at the cliff, or at t is equal to 0, or initial time. Okay, so we all agree with this. We're going to put it here. That's where it's going to be localized. But then Henry wants to make life interesting and put the positive y down, and therefore x will be perpendicular. Whether x goes towards the right or towards the left, it won't have any effect on the equation. Okay, let's do this. So, so we have positioned the original current stem at the initial time and initial position. What does the position of this origin affects and how? So what does the choice of this origin affects and how? Don't go too fast, Henry. Don't go too fast. Let's go step by step. You're entirely right, but let's go step by step. First, because not everybody is on the same page as you are. Thank you, thank you. So, the position. Is it the sign? Is it the value? Is the position of the origin affects the velocity or the position or the acceleration? Let's be very, very precise. So make sure you take notes. The position of the origin affects which variable on those equations, and how does it affect it? Almost. Let me give you an example. New page. I have a point here. I have decided to put my origin here, and now I can measure its position. Versus, I'm going to change the location of my origin here. If I move my current stem from the green to the blue, what is affected with respect to this point? Is it its velocity, its position, its acceleration, the cut of its underwear? What? It's not a tricky question. You know the answer. Very simple. Position. Right? In this case, the position is 3x and 3y. 3 and 3. But in this one, it's 1, 2, 3, 4, 5, 6, 7, 8. And the y is blah, 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 blah. So obviously, by moving the origin, you move your axis. Therefore, you move your datum, you move your reference frame, you move the reference from which you measure positions. Are we all agree with this? The current stem is used to measure position first. All right. So the location of this current stem affects which variable? If we agree that it's something to do with position. The fact that we decided to put the origin at this particular position and at this particular time. That's exactly what we're doing, Michael. We have put the origin when and where the ball is thrown, right? So when you said 2, Johnny Marr, what do you imply? we all agree that the location implies and has a consequence on the position. Which variable deals with position? Is it x? Is it v? Is it a? Is it t? X. Okay. Now, is it all the x's, x and x naught? Is the origin will affect my x, or is it going to affect my x naught? Go back to what we've done 10 minutes ago. Or go back to your notes, because you've taken notes, right? Make sure you do take notes. Yeah, excellent. E affects x naught, the initial position. Write that down. The location of the origin of your coordinate system has always an effect only on the initial position. In our case, x naught. The location of your coordinate system only affects your initial position. That's all it does. Okay? Now, Henry tried to mess us up by choosing first y in this direction and y down. So if he chooses y in this direction, which is where the kinematics occurs, then we know right away all those little buggers are y to start with. That's our first change. Okay? So first, we chose our y-axis to be vertical, and our kinematics is taking place in the vertical direction. Therefore, we make that change. First step. Second, we decided to put the origin at the initial time. Therefore, we will agree that it will affect x naught, the initial position. Since now we're dealing with y naught, how is y naught going to be affected? Is y naught is going to have a particular value, and if so, which one? Excellent. So second step, the location of origin allows us to nuke all the y naughts. Whoops. Nice. Okay. So, origin of our coordinate system affects our initial position. The direction of our axis is going to affect what? It's going to affect two things. So we are clear about the effect of the location of the origin. We are clear about the effect of the choice of our label for our axis. Now, what is the consequence of the positive direction of our y-axis? I agree. This will cause our position y to become positive at some point. Not always, though. But I'm still in the process of simplifying my equations. So think about those terms. The choice of your positive y going down will have two effects. What are they? Excellent. A is positive, because free fall tells us that the direction of acceleration is down. If you chose y-axis to be positive down, then A will be positive, or will remain positive. And I'm sorry, I'm going to typo here. Therefore, that this will not be changed as we did last time. We're going to keep it as a plus. Good. And thank you, Michael. It will also affect the initial velocity. Before, we didn't have to worry about the initial velocity because it was 0. But now we know that initial velocity is up. And we assume that everything that goes down is the positive one. Therefore, V naught is going to be negative. Okay? Next, what does free fall tell us? constant acceleration, yeah, but I'm still thinking about simplifying my equation, remember? Excellent. A can be replaced by G, and then one more thing. It is going to be equal to positive 9.8, absolutely. One more thing. Oh, the nut thing? You mean V nut? Well, look at V nut. Its direction is up, right? Look at your Y. Positive is down. So by property of a vector, we need to change the sign of V nut. That's what we did. Does it make sense, Eric? Perfect. Yes! Thank you, Tyson. Free fall. Because free fall assumes that A is equal to G and not equal to 0. Therefore, we have to drop the first equation. Okay? So those are our three simplified equations. Obviously, they're a little bit more complex than the previous problem because our process is a little bit more complex. It goes up and it goes down. So, you know. Okay? So, let's take a break. It's 6:02. Meanwhile, during the break, look at the questions and ask yourself, which equation are you going to use to answer question A, question B, question C, question D, question E, question F, and question G. So that when we come back in 10 minutes, you know exactly which equation to use. As you go through that process, you will be forced to think about something quite interesting, which is this one. The questions of the problem, Jamie. A, B, C, D, E, F, G. We're doing problem 5, remember? Okay? So, start thinking about what will be interesting here. Which is what we call apogee. Alright, quick break. Let's meet again at 6:13. Yeah, apogee, apex. Now, what did it tell me last semester? Because of my stupid accent, apogee was understood to be, I forget. But if you sound like something you know, let me know so I can clarify that it's not it. I forget where it was. Anyway, see you in 10 minutes. No, it was an RG. Close though. Sounds like Applebee's. Yeah, they all sound, but there was something else, which was misleading. If you don't think about it, that's good. You won't be misled. Sorry about that. Stupid accent. Not that one either. Okay, I'm sorry. Let's forget it. Obviously, if you cannot think about it, then it will not confuse you. I think it was a little bit confusing last semester. Okay, 6:04, so let's meet in 6:14. So again, please go through that process, identify which equation you're going to use for each part, A, B, C, D, E, F, G. And as you go through that process, ask yourself about what's happening right here at the apex or the apogee. All right, so let's keep going. First question, calculate the position at t is equal to 2 seconds. Which equation are we going to be able to use to answer part A? People who answer second, could you justify why? His position on the... Oh, I'm sorry. Maybe let's clarify this. 1, 2, 3. Because we scratched the top one. But, sorry. Okay, that's what I was thinking. Good. First one, right? Perfect. Now, since we already put this negative sign on V naught, we just plug the absolute value. So it would be Y, is equal to negative 25 times 1 plus 9.81 times 1 squared. All right. Is this going to be positive or negative? Do you know it is negative? We did it earlier. Can anybody answer him? Yeah, we put the negative sign here earlier. Remember why? Because this is the direction of E naught. This is the direction of a positive, down. So again, please guys, take notes. No. Excellent question. He always just to review. Good. So as you plug numbers, we see that y will be negative in this case. Does that make sense? Absolutely. It means that we're going to be somewhere around here. And this is below our x-axis. Therefore, going to be, 2 seconds. Woohoo! Thank you. So if we have 2 seconds, is it still negative? Yeah, it's still negative. So we're still good. Thank you, Mabel. Okay, so the sign should always be consistent with your coordinate system and your diagram. Perfect. Next, calculate the velocity at t is equal to 2 seconds. Which equation are we going to use? 1, 2, or 3? Perfect, 2. For velocity will be, again, negative 2.5 plus 9.81 times 2. Is this value going to be positive or negative? Negative. Does that make sense? What does the negative sign tells us with respect to velocity? Excellent. The direction. The velocity is going up. Since we decided, due to Henry, that everything that goes on is positive, then this is going to be negative. Confirm right here. Thank you, Henry. You had a little bit of space. Good. Obviously, if we know how to do A, we know how to do B. Next one. Calculate the velocity of the rock when it's located at 15 meters above the cliff's edge. So we're looking for velocity in terms of a position now. Which equation? First, which equation? 1, 2, or 3? Are you sure about the first one? Do you know the time when the object will be at 15 meters? Excellent. So third. We're stuck with the third. The third is always tricky to use. Be very careful because he has a square. So as you plug numbers and solve for v, you have 2 solutions. That's the tricky part because of the square again. So be careful. This comes from this. We're going to end up with negative 25 again, squared, plus 2 times 9.81. And what value are we going to plug for y? Excellent. Again, the negative sign comes from vector property. If we're 50 meters above the cliff, and this is 15 meters, and it's above the cliff, then obviously this position is below our x-axis. So everything above is negative, because again of the choice of our y-axis. Therefore, we need to put the negative sign. Excellent. So again, this is the key. This will tell you what sign to put and when. Good. Now, which solution you're going to keep? The positive or the negative? Mathematically, you always have more solution than physically. Sometimes we keep them all. Sometimes we nuke one of the two. In this case, do we need to keep both solutions, or keep the positive one, or keep the negative one? And that's a tricky question. Well, not tricky if you think of the process itself. That's why I drew a line. Is this particular position of 15 meters above the cliff going to be crossed one time or two times? Two times. What is the direction of the velocity the first time? Is it up or is it down? It's up. Therefore, it's going to be the negative solution. What is the direction of your velocity as it crosses at 15 meters the second time? It's going to be down. Therefore, this one will be positive. Excellent. Therefore, we need to keep both solutions. Both counts. Excellent. So again, the key to science is our coordinate system and our diagram. Excellent. Good. Next, D. What is the velocity of the rock when it's located 25 meters below the cliff's edge? Which equation? 1, 2, or 3? Same. 3. Excellent. Now, what are we going to put for Y? If we are below the cliff, somewhere on here, 25. Positive. Why positive, Mabel? Because if we're here, remember, our datum is the x-axis. That's why it's important to draw it. We're above the x-axis because the positive y is up. Therefore, everything here is positive, everything here is negative. Does that make sense? That is indeed positive 25? Excellent. Now, next question. Which solution are we going to keep? Here. The positive one, the negative one, or both? Excellent. Only the positive one this time, because it crosses this position only once. And as it crosses this 25 marker, the velocity is down, therefore positive. Excellent. So as you can see, it's not hard at all, but we cannot rush. We have to do one step at a time, and always refer to our coordinate system and our diagram as we substitute numbers. And that's it. E. Okay, here the fun begins. Calculate the maximum height reached by the rock. Maximum height refers to which variable? Y, V naught, G, T? Which one? Y. Excellent. Therefore, we can only use equation 1 or equation 3, because those are only one who has a Y. The problem is, we need to do something else. If we use the first equation, we need to know the time it takes to reach apogee from the edge of the cliff. And if we use equation 3, then we need to know the velocity at the maximum height. So which one do we know, and which one are we going to use? In other words, what does maximum height tells us? Maximum height is our apogee, right? What is specific at apogee? Excellent. Make sure you write that down. Keyword apogee means that the velocity in that dimension is 0. For our case, Vy is equal to 0. Therefore, this V is 0. That's our condition. Therefore, now we can use equation 3, and we have 0 is equal to negative V naught squared plus 2GY. Okay? Again, please make sure you write your math correctly. Don't forget the parentheses. Otherwise, your answer will be wrong. As you saw for Y, you end up with negative V naught squared divided by 2G. Is everybody okay with the algebra? Be careful. Writing your mathematics correctly is very, very important. Being sloppy when you write your mathematics often leads to mistakes. Therefore, Y is going to be negative. And it has to be, because we're here. We're in this range, below the x-axis, so it gotta be negative. We cannot have a positive answer. Okay? Next, calculate the time it takes to reach that stupid bugger, which is the maximum height. Now we have choices. Which equation are you going to use? If we're looking for the time to reach a particular height, so the condition is position. Michael suggests the second one, Mabel the first one. Excellent. We can use either or. If we use the second one, how are we going to plug the values? What is the second one going to become as you plug the micro values? What is the left-hand side equal to? Yeah, we use the same condition. Apogee, velocity is 0, therefore we have 0 is equal to a negative V naught plus GT. As you solve for this, V is equal to V naught over G. Gotta be positive. If you end up with negative time, you know something is wrong. The only time you can end up with a negative time is if you solve a polynomial. One of them may be positive, the other one negative, and you only keep the positive one. Excellent. That's going in seconds. Second option, Mabel suggests, well, I want to use the first one. You can. Y is going to be equal to negative V naught Z plus 1/2 GT squared. Are you going to substitute value over here? What goes for Y, the left-hand side? Excellent. The result of part E. So, this suggests that if we use equation Y, we have to rely on the accuracy of the answer of the previous question. Hence, equation number 2 is safer. Plus, it's faster. So that if you goof on part E, if you use equation 2, you won't goof on part F. But if you use equation 1, then you're going to goof again. Excellent. So this will become negative V naught squared over 2G. And you see your polynomial. Do you remember how to solve a polynomial? How to calculate the roots? You don't have to type the answer, just say yes or no. If it's no, you have to review your Math 103 or high school algebra. If yes, you're good to go. Is everybody okay on how to solve this? Excellent. ax2 plus bx plus c will give you minus b plus the minus square root of b squared minus 4ac, everything divided by 2a. Good. Now, as you saw for this, you have two possible scenarios. You either are going to obtain two solutions or one solution. Right? Okay, so you remember this formula? That's for T. Obviously, this dictates you're going to get two solutions. If you're dealing with time, you're always going to get a positive one and a negative one. Mathematically, two solutions. Physically, you're going to only keep the positive value because, as we said, in classical physics, we only go forward in time. However, it might be a case where this will give you only one value. By looking at this functional form, how is that possible? Which term needs to be 0 for T to be unique? Just a math question. I'm making the claim that you could only have one solution sometimes. what must happen for t to only have one solution? Well, we need to get rid of the term that has plus or minus, which means that this term under the square root goes to 0. If this term is 0, or if b squared minus 4ac happens to be 0, then you only have one solution. And it got to be positive if you're solving for time. Okay? Physically, this will happen at apogee. So in this particular case, as you're going to apply this technique, you will see that the square root will be equal to 0. Because physically, there is only one case. That's the apogee. But if you're not at apogee, you're going to obtain two solutions. And in those cases, you only keep the positive one. Okay? So remember that, if you like to save time. At apogee, you don't even need to calculate all this. Just calculate the ratio of negative b over 2a. Bang, you go faster. Or use a calculator. Okay? Questions so far? Oh, did I start the recording? Yes, I did. Woohoo. Perfect. All right, last question. Calculate the acceleration when the rock reaches its maximum height. And this is a trick question, unless you know your definition from your notes. Excellent. Thank you, Henry. Negative 9.81 meters per second squared, and its direction is down. So this is a common mistake. It's not because the velocity is 0 that the acceleration is 0. I repeat, it's not because the velocity is 0 that the acceleration is 0. We are doing a free-fall problem. Oh, my bad. Thank you, Tyson. Okay, this is a free-fall problem. Definition of free-fall: the acceleration is 9.81 and its direction is down. That is valid at every time that we choose to use and calculate the acceleration. So from t is equal to 0 to t is equal to infinity, a is still 9.8 meters per second squared, and its direction is down, even at apogee.